Okay, we're going to start. Fine to see. All right, let's get started. Are you in the right place, first of all? Yes. Okay, this is Math 270, Calculus 1. Are you in the right time? Okay, so this is me, Mark Ashbrook. You can call me Mark. If you're uncomfortable with that, then just anything respectful is fine. These are our TAs, and so only Annie couldn't make today. Roy has class during this time, but Kirk is here. So this is Kirk. If you have recitation on Friday, you're with Kirk. So there's two recitation sections this afternoon. Kirk is your man, and you will go today. Okay? And if you have recitation Monday, next Wednesday, you will go. It won't be kind of a real recitation, but attendance will be taken. You'll do a short kind of survey, and then he'll let you go. Okay? So it'll be an easy, short recitation today. And it's recitation, not resuscitation. Okay? All right. This is a good. So he's here to help you. Okay? So. All right. So let's talk about some basic nuts and bolts. And he'll also be, like during class when I put you to work, he'll be along with me walking around to help you. And so that's not ideal here, but we'll do our best to get to you guys in the middle. All right? And just as a warning, I'm going to kind of make it my effort to find us a different room so there's a little more space and we can get to all of you easier because the interaction between us and you is going to be crucial in this course. Okay? So we want to facilitate that as best we can. So just stay tuned for announcements that we've got a new classroom. So I'm going to work on that in the first week or two. You should have received some emails from me. One regarding textbook and Top Hat. I sent another one just an hour ago. So if you're not receiving emails from me, you haven't received any, then you need to get that taken care of in terms of contact computing. Whatever email address you're using, you got to get your ASU email to be forwarding to your main address correctly. Because I will send out emails like at least once a week that are important. So make sure if you haven't gotten emails from me yet, that you take care of that. Yeah.
Oh, hi. That was just me. I was just wondering, since I dropped 266 and I accidentally bought the book because I gave you a week ago. Yeah. Do you know the bookstore will get it back?
Usually it's within. Right when you buy it, you get a full refund. If you haven't opened it right at the beginning, I think there's some kind of period. Full refund? Okay, so that's why I tried to warn you a couple weeks ago. If you bought that package or the book or the Pearson My Math Lab, we're not using it. You don't need it. Go get a full refund. Okay? So I guess today's the last day. Thanks for bringing that up. Okay.
I'll also be the police. So
yes.
If you have your phone on, or not, put it away, and also Facebook, no social media, something like that, or you'll hear my voice saying, put it away, or turn it off, or something like that.
Okay, yeah, so this is definitely not going to, even though it's a lecture, it's a full lecture, and there's many of you, this is not going to be the time to turn your brain off and just go into note-taking mode, or turn your brain off and go into Facebook mode, okay? You won't be able to do that and succeed in this course. And so he's going to be making sure that you are staying on task and not getting trapped in your screen with something that's not about calculus, okay? So let's talk about some nuts and bolts. Okay, here's the best way to to contact me. mark.a@asu.edu. Mark.ashbrook also works, okay? Mark.a is nice and short. I'm addicted to my email, okay? So that's not good, but it's good for you because I usually can get back to you within sometimes 10 minutes, but usually at the longest a couple hours, okay? So Kirk is for today's recitation. Next week, Monday and Wednesday recitations, I'm not sure who's who. So you can jot them both down. If you don't have Kirk, it's going to be either Annie or Roy. It's going to be your TA. Certified Calculus Geniuses. Annie, Kirk, and Roy, okay? These are your friends, they're your allies, they're going to help you.
And it doesn't agree with what it says on your schedule yet. So it'll say that you have Roy for Friday today, but that's not accurate. So even though it may say that you have Annie or Roy or me, you'll find out by who shows up on your first recitation.
Right, so the way it is scheduled in the ASU system is not the way it's going to be. They're going to they're going to flip around. But if you're Friday, you got Kirk. All right, so Blackboard is going to be our home base for the course. All right, that's where you'll, syllabus, get syllabus, we'll look at that in a second. That's where you'll find your written assignments and other course docs. That's where you're going to see exam results and grades and class videos. Okay, so right now, we are recording. Okay, so every day I'm going to make a video of class. So the visual part is everything that's on the screen. I will do everything through the screen, and so that all gets recorded, and then the audio is just to pick up the mic on my laptop. So you get a full reproduction of class. That by no means is a reason to not come to class. Coming to class is required and crucial, okay? So the video is just for the second time around. It's for the reinforcement, because you could walk out at the end of class and say, wow, I really got that, like 80, 90%. I think I've got it. But if it's the first time you've ever seen it, 12 hours later, it's half gone. And 24 hours later, it's mostly gone. Okay? And that's what the video is for. Watch those videos soon after class, and that's a great time to take formal notes, because you can pause it and take really good notes if you want to stay more attentive and not worry about so much writing during lecture. Then you can make your notes later. Okay? So this is going to be a hugely important resource for you to review class, okay? And then grades will be posted on Blackboard, but I only use Blackboard to post individual grades. It will try to compile something. It will try to give you a total grade, an average grade, an overall grade. Just ignore all that. I'm sure I'll have to say that again. But I only use Blackboard to keep track of individual grades on homeworks and tests. So anything that's trying to calculate your overall grade, just ignore that, okay? All right, so we will be making a lot of use of this graphing software. It's kind of unfortunately called Graphing Calculator, because it's not a handheld graphing calculator. It is software that you will download, and you'll have it, hopefully, you have a laptop. That's the best place for it, on your laptop, or else whatever computer you use the most. You will need this. It is integrated into the course, okay? So it does everything that a handheld graphing calculator does, and 100 times more, and 100 times better, okay? And you're getting it for free. You're getting it for free, okay? So many students, after they start using this, they really appreciate it, and then they will always use this whenever they need a calculator, okay? And we will be taking time to teach you how to use it, and we can do some very powerful things with it in relation to calculus, okay? And so I hope you appreciate that. All right, so we've, by now you've hopefully gotten some alert to this. This is kind of, you've heard of clickers before. This is similar to a clicker system, but you're using your own devices. So you need to bring internet with you to class, whether that's a smartphone, a laptop, tablet, whatever it is. You bring your internet to class, and that's how we'll be answering or giving quizzes and just questions. And we'll use that every class. We use that every class for maybe 2 to 4 questions to make sure that you're staying alert and staying attentive. Okay, last requirement. You will need 50 3x5 note cards. Everyone needs 50 3x5 note cards. So find them in your desk or buy some. Okay? Bring them to every lecture. Bring them to every lecture. 50 3x5 note cards. Or bring a handful to lecture. You don't need all 50, but you need some for every lecture. Okay, so let's take a look at Blackboard and Syllabus. And then we'll answer questions. So here is our Blackboard page. I've put a checklist of what you need to do for Monday right here on the first announcement. Okay? Syllabus. Get enrolled in Top Hat. We will use Top Hat on Monday. We'll practice and we'll do actual questions on Monday. So you've got to be enrolled by Monday. Buy your 50 note cards. There is a written assignment for Monday. And then download the software. To download the software, Graphing Calculator, it's right below in the next announcement. It gives you instructions for Mac and Windows. And then here's the registration info so that you are getting it for free. We'll be using that extensively, okay? All right, so let's take a look at, so over here's the syllabus. We'll look at that in a second. Readings and homework. So here's your first assignment, due Monday, August 25th. When you come to this page, the readings and homework, please read carefully. I'm going to be providing you with documents that are anywhere from 4 to 15 pages long. Homeworks will be taken from those. So I posted this first one, Module 1, Section 1. And so you're not going to do the whole thing. I think it's at least 10 pages long. So you've got to read carefully. Read pages 1 through 3. That sounds better than 1 through 14, right? Read pages 1 through 3 of Module 1, Section 1. And then you're going to answer reflection questions 1 through 6 from those pages, 1 through 3. Okay, do that on your right, or print that out on your own paper. And we'll collect that at the beginning of class Monday. Okay? So that's reading. So office hours. So here you can find email addresses and office hours of me and your recitation TA. Once Annie, you still have to update, okay? But if you're wondering about office hours, we have that in the course menu. Office hours right here. Top Hat info, if you're having any difficulty, is pretty self-explanatory. But if you're having any difficulty getting set up, there's some resources, a quick start guide, a user manual, and then you can email. There's a support email link. Okay, let's see, what else? Top Hat info. Okay, so that's all we need for Blackboard. Again, you got your checklist right there on the announcements. 5 things for Monday. All right, let's look at the syllabus briefly. Okay, so I'm not going to go over this except for there's something important that we need to let you know right off the bat. Exams. We will not take exams in here, and we will not take exams in recitation. We're going to take exams on Wednesday evenings, okay? We have reserved a room from 6:15 to 9 p.m., okay? You don't have to be there right at 6:15, but I would recommend at least an hour and a half. So you can come anytime you want, but know that exams will be collected at 9 p.m. Do you all know kind of what type of test taker you are? So you know that you're pretty fast. You could come at 7:30 or 7:45, and you're pretty sure you would get through it. I don't recommend that, okay? If you all want to come at 6:15, that's great. You can all come at 6:15. And I recommend that you leave yourself lots of time. So the first one is September 10th, and then we got October 8th. And then the 5th and the 12th. The 12th only if you don't pass Mastery Number 1. And then the 3rd. So I'm going to let you know right off the bat here that you need to carve out those Wednesday nights for these tests. Okay? So you know right off the bat.
Yeah, question.
Thank you.
Yeah, so it doesn't matter what time I come for the test, like it can be somewhere around 6:30 or...
Yeah, if you want to come at 6:30, 6:45. Just know, I'm going to collect the exams at 9 p.m. You can't work any later than 9, okay? Yeah.
You can turn them before the night.
Yeah, so yeah, you can come you can leave early too, that's right.
So you get all the time from 6:15 to 9 to take the test?
Always 6:15 to 9 on those Wednesday evenings.
The whole time, so there's no time limit?
There's no what?
No time limit until 9?
Right, so if you are allowed, if you want 2 hours and 45 minutes, come at 6:15. And you get 2 hours and 45 minutes to take the exam. And if you're done in an hour and a half, you can leave. Okay? Write these dates down now. So you can't talk to me the week before and say, oh, I have a class on Wednesday nights, and I can't do this, right? So I'm telling you this now so that you don't make any other commitments. Okay? All right, cool. So here's the breakdown for grades. The homework's 20%. There's a lecture grade that includes Top Hat, and we'll have like a 10-minute written quiz once a week. And attendance is 15%. The exams are 45, and the final is 20. The way recitation will work is it's not included in that 100%, but it'll be a penalty for absence. Okay. So if everyone gets a cushion of 1 miss throughout the semester. Okay. After that, your overall course grade starts to go down. If you miss, so by the time you've missed three times, you're down 3% your course grade. If you miss 4 times, so that actually is right there is I could give you an E for the course for non-attendance. This is saying for 4 absences, you basically are down half a letter grade, over half a letter grade. Okay? You gotta go to recitation. Okay? You gotta go to recitation. Okay, so the rest is, this is all, fine print, important, but we won't talk about it. You're responsible for it. So this is kind of what we talked about. Blackboard, graphing calculator, Top Hat. Web work, okay? So in the second half of the course, we'll use an online homework system. And so we don't even talk about that now. That's free too also. That's totally free. And when that starts getting close, then we'll learn about that. You will need an access to a printer. Occasionally, some of the homework assignments require that you print out some graphs. So somehow you need access to some printer. Any questions about the syllabus? Oh, my office hours are Monday, Tuesday, and Wednesday, 2:45 to 4:15. So basically after this class on Wednesdays and the same time on Tuesdays. Question?
For recitation,
Yeah.
are you gonna have to purchase the recitation book? Or
No. So don't purchase a there's a recitation book. You don't need to purchase that.
Are you gonna need us to bring our laptops every class for the graphing calculator?
Not every class, but I'll try to let you know ahead of time.
Okay.
Yeah, we will be using graphing calculator in some classes, and so then I'll try to give you fair warning.
Do you want us to use that graphing calculator on the exams too, or can we use it for other?
No, so the exams are written so that you don't need it. You don't need graphic calculator on the exam. So you can bring a handheld for the exam. Other questions? These are good questions. Any questions?
Wait, so the lab calculator's on the exam?
Yeah. You can use a calculator on the exam.
What is the text for this class?
It's so the first half of the course I'm providing you those documents in the readings and homework on Blackboard. So the first one, that Module 1, Section 1, is right there posted with. So there it is. There's the first section of the first module. And so I'll continue to load those up as you need them. Other questions? Yeah?
Does Top Hat require payment of a subscription?
It's about $20, $20 to $25.
$66 after tax.
Yeah. And that's instead of purchasing the $100 textbook. So hopefully that's a good thing for most of you. Any other questions? Yes, sir.
This one's more like situational, but I recently purchased the Top Hat, and I got it for store pickup, but it's not ready.
Okay.
So what would I do come Monday when I need it?
Can you just enroll online and then return that one?
Sure, I guess, yeah.
Yeah, if you're not forced to pay for that first one, then just enroll online. So in the enrollment process, I can show you that. So through the enrollment process, you can just pay through that or go to the bookstore and buy the little packet with a subscription. So it's either or. And you'll click the green button and it'll take you through. Okay, it'll take you through. And then our course info, if you haven't done this yet, I think it posted it. Syllabus, let's see, Top Hat. So here's the info you need. If you click on Top Hat in Blackboard over here, info, that's what you need. You need course name, F14 MAT 270. There's the course code. That's what you need to get enrolled in our course if you haven't done it yet. Yep.
I tried to enroll in Top Hat. I tried to get the subscription, and it wouldn't take my card because it was their card.
Okay.
So I need to.
So let's do that after class. Let's talk about that after class.
Did I hear you correctly to say that you want us to download a graphing calculator program for our laptops?
The one that's on, the instructions are on announcements.
But we can't use that during the test.
That's
We
right.
have a
But the
separate
tests are,
graphing calculator.
yes, right. On the test, you just bring a handheld. You won't use your laptops on the exam. Too hard to police. Okay? And the exams are written as such. They're written for that.
But basically, we need both.
Yeah. But this is free. Yeah.
Are there going to be any calculator checks before the exam to see if we have any of the programs or we got the calculator set on?
Yes. Other questions? Other questions? So, an easy solution, right? Don't cheat with the calculator. Are we good? Okay. So let's do some math. So, it would not be incorrect to say that MA 270 is about one thing. It's about quantities, okay? That would be not an incorrect statement to say that Calculus 1 is a course about quantities. So we're going to talk about what we mean by that. All right, so instructions on a drink mix container say that 12 tablespoons of powder should be mixed with 50 ounces of water. So I want to introduce a way of modeling this visually. Okay, I want to model this visually, that 12 tablespoons of powder should be mixed with 50 ounces of water. Probably something you haven't seen before. And it's what we're going to call a bar diagram. Okay, bar diagrams, where the length of the bar represents the value of the quantity. So here, this is what we mean. We're going to use horizontal bars, and the length of the bar represents the value of the quantity. So, looking at that setup and looking at these bars, how do these bars represent the situation that I gave you? What about, so is the longer bar is not the water, but the what? So water is just an object, right? So the quantity is what it is about the water that we're measuring, right? Yeah, ounces, right? So volume, maybe volume of water. Okay, and then the shorter bar? Yeah, tablespoons of. And so what's the length of that bar? The top bar. What's the length of it? 50, right? So the length of that bar is representing 50 ounces. And the length of the lower bar is representing 12. Nice, easy start, huh? Don't get your hopes up. So we want to use this to answer this question. How many ounces of water should be mixed with 4 tablespoons of mix to achieve the right taste? Use the bars to illustrate the solution. So when you read that question, here's where some of your minds may go. You say, oh, that's a problem like one of these problems. And then what do we do? Plug in, cross multiply, solve, right? Okay, so we don't want to do this. We want to reason about these quantities to solve this. So we want to use reasoning about what's going on here rather than kind of a procedure that you remember from algebra. Okay? So how can we reason about this? So how much water should we mix with 4 tablespoons of mix to achieve the right taste? Christian?
Well, if you're using lines, 4 tablespoons of mix is a third of your 12 tablespoon lines, so that would make it a third of your 50-ounce line.
Okay, so you're looking at this 12 tablespoon, you're saying a third of that length would be how much?
4 tablespoons.
4. So we could break that up into thirds, right? I don't know all your names already. He was in my class before. All right, so a third of that is 4. So then you reasoned what?
So if a full bar is equal to a full bar of water,
Yeah.
then a third should be equal to a third.
So if 4 is a third of 12, then he's saying we need a third of 50 to be the right amount of water. Makes sense, right? Do you see how vastly different that is than this? Do you see the difference? Okay, and that kind of reasoning is a lot more powerful than memorizing procedures. Why? Because if you get a problem where your procedure doesn't work, what are you going to do? Right? So understanding and reasoning-based solving is going to take you a lot further because then things can change a little bit and you're okay. You can still handle it. Procedures are very limiting. They're very limiting. Okay, so we're going to break the 50 into 3. And so how much water is that corresponds to 4 tablespoons? I'm not asking for a final answer, but or where does it come from? Like what are we saying that amount of water is? A third of 50. 1/3 of 50. And how do you find that? Yeah, so we could take 1/3 times 50 or 50 divided by 3, whatever you want. So I'll just do multiplication. So we want 1/3 is 50 ounces. Can I be done right there? Is that valid representation of the answer? Yes or no? Some are saying yes, some are saying no. Is it uncomfortable? It shouldn't be uncomfortable. That's perfectly legitimate. And it's even better for you. So what's the advantage to an answer like that?
Because you're going to get a decimal when you plug that into a calculator.
Okay, it's exact. That's true. What else? What's another advantage? Yeah, it shows the process, right? It shows the process, that's helpful. So that's a perfectly legitimate way to write an answer. Now let's get a decimal approximation, because if we're actually measuring the water, we need a number, right? So it's for actually measuring, and so that is 16.67 ounces.
What do you like on a test, actually, the first or the second?
It depends, right? So in the test, we're looking to see if you understand stuff. Either answer shows you understand what's going on. Okay. All right. So let's take this stuff. Okay. Questions on that example? Yeah. What time are we out of here? 1:30. 2:20. 2:20. Cool. Question.
So you don't specify decimal points, or if you do?
Well, so what's appropriate? So putting 5 decimal places or more is not appropriate. So 16.7, that's appropriate. 16.67, that's appropriate. So it's not, depends on the context, right? But 0.666667, that's way too much precision for ounces for mixing drink, right? That makes sense, right? So do what's appropriate, Other questions about what we see up there right now? Okay, cool. So same situation. That's a little bit different. We want to use bars, solve and illustrate how much powder would be required for 180 ounces of water. So you're going to take a minute and see if you can do this yourself. So this is a little bit different. You got to be a little creative. Be creative. So I'll give you the bars. Again, none of this setting up fractions and cross multiplying. We want to use the bars to reason about this, but I'll just give you hints. This one you're going to approach a little differently. Okay? Go, see if you can do it. You can meet the person next to you, talk as you do it. Discuss. Okay, so for this one, do I want to make the length of this bar 50? Like before, it was 50, right? So do it 50 again? If I make that 50, then what happens? Well, we could yeah. So, but we'd be in the next classroom, right? So maybe not that far, but we'd be off our paper, off the screen. We'd be over here trying to model what 180 was, right? So what can we do instead? Yeah, so let's, instead of doing our 50-12 bar, let's make that first bar 180 this time. Now, what's the length of the bottom bar? Some people are saying, well, we're trying to find, right? So that's like our unknown. Okay, where do we go from here? So somebody new. So take it over from here if you set it up this way. Yes, sir?
Well, you could make the 180 ounce line, you could
section it into parts of 50.
Nice. Okay. So something like, let's see. I'm gonna try this. So it's like 50, and then 100, and then I did pretty good. Okay. So this is 50 right here. Okay, keep going.
And then you would basically just do a proportionate division of the smaller line because there's 50 ounces to every 12 tablespoons.
Okay, so now you want to start bringing the. Let's have someone take over. So how do we bring the tablespoons of powder into this now? Yes, sir.
It becomes like you take 3 times of 12 tablespoons, and then you have 3/5 of the 12 tablespoons. So you have to do.
Okay, but so how will I want to bring in this bar. So you're kind of giving me some calculations. I want to bring this bar into solving the problem. So how am I going to bring this bar into it? In the back.
You could break it off into sections of 12, like 3 different sections of 12.
Okay, so he's saying that this is 3 and what, 3/5 of 50 here, right? So we want to break this bar up into the same 3 and 3/5, something like that. So 1, 2, 3. Okay, and then what? So how much is that?
Section represents 12.
12, right? So this, the 50 corresponds to 12 tablespoons. Right here. It's 12. Now we're making some progress. So how much powder are we going to need? I'm not asking for a final number. Yes, sir. Yes, sir.
3/5 of 12.
What's that?
3/5.
3/5 of 12. Is it 3/5 of 12? That's how much powder?
3.
You got the right idea, but 3 and 3/5, right? So 3/5 is just, the 3/5 of 12 is just that right there.
Right. Okay.
So we need 3 and 3/5 of 12 tablespoons. And how do we get that number? How are we going to find what that value is? Is it 18/5 times 12? And let's get an approximation. Well, that probably we can get exactly. What is that? 14 point? Okay, so nice and loud. One person, nice and loud.
43.2.
43.2, thank you. So maybe an easy problem, but if we're gonna be thinking this way, we need to practice because you may have never seen something like this before because you're used to the set up the ratios and cross divide or cross multiply and solve. But this kind of reasoning about quantities can take you a lot farther when it comes to all kinds of problems in calculus. Okay. Questions on this one? Does it make sense? Okay, so let's talk about quantities, numbers, and operations. So we're going to focus on some operations here. So if our resulting quantity is a scaled version of another quantity, what operation gives us a scaled version of another quantity? We've kind of been doing it here. Like what do? We scaled the amount of water to be 3 and 3/5 of 12. We scaled it, so we took that 12 and we scaled it up 3 and 3/5 to get that 43 or whatever. What operation was that? That was multiplication, right? We took 3 and 3/5 times 12. That was multiplication. So a scaled version of another quantity is the result of multiplication. So we've already seen it. So here's 2 examples. A tree shadow is 2.8 times as long as the tree is high. It's just that first example. So can we use a simple bar diagram to illustrate that? So could you draw a bar diagram to illustrate that a tree shadow is 2.8 times as long as the tree is high? Do it real quick. Everyone do it. Does it look something like this? I don't know if it's exactly, if my portions are exactly right on the diagram, but it should look like something like this. And so my top bar is what? What does it represent?
Shadow.
What about the shadow? Length of the shadow, right? And what's my bottom bar? Height of the tree. And what does scaling have to do with this situation? What does scaling have to do with it? A scaled version of another quantity. So how can you, what does this have to do with scaling?
Take the original quantity and make it larger based on that.
Okay, and what's our in this case, what's our original quantity?
The height of the tree.
Height of the tree, you're just going to scale it up by, to get
The shadows.
shadow length, right? That's the idea of scaling. Okay, so the smaller bar is scaled by 2.8 to get the length of the top bar, which is the length of shadow. Okay, how about the other one? So the number of checkers in 12 rolls is 12 times as large as the number of checkers in one roll. Go. Make a bar diagram for that. Does it look like that? And what am I modeling with the top bar? Number of checkers in? 12 rolls. What does scaling have to do with this example? So who could tell me, explain how this is an example of scaling? Somebody new? Finding length of 12 times, what about the original roll? What is
Number of checkers in one roll versus 12.
Okay, so we start with the number of checkers in one roll, and it gets scaled by 12, and that shows us the length, or the number of checkers in 12 rolls, represented by the length of the top bar. Easy. This is a little bit different, so let's see what you make of this. This is a little different. A car travels 72 miles per hour for 4.6 hours. This is different. So let me just first off tell you that as you attempt to kind of model the situation, neither of those bars are going to represent speed. Okay? Neither of those bars are going to represent speed of 72. That being said, see what you can come up with here. How can we use this bar diagram to represent this situation? Neither of those bars, though, is going to stand for speed. So everyone think about it, work on it. Do you have a question about it or an answer? Okay, so let's everyone work on it. Compare with the person next to you. Okay, somebody new. Who has an idea for what those two bars will represent? Yes, sir.
The bottom one will represent the distance that the car travels in 1 hour, which would be 72 miles. The top one will represent the distance traveled by the car, 4.6 hours. which is what we don't know.
Okay, so he's doing something different than I intended, but you're doing the distance in 1 hour and the distance in 4.6 hours.
Yeah.
So you made them both distance. That's fair. I mean, I didn't give you enough structure that you would have. So if you did both distance, like it would be 1 hour and 4.6, or the distance traveled in 1 hour, the distance traveled in 4.6 hours, totally valid. Anyone do something different? Yes, ma'am.
Both of them represent the hours, so one is going to be 18 hours and one 4.6.
Where's the 18 hours coming from?
About 70, I just did, 72 divided by 4.6 is going to give you around 18 hours. So
Is that a number of hours when you do that? When you divide 72 by 4.6? That 72 divided by 4.6, I don't think that's going to give you something helpful. Somebody else? Yes, ma'am.
First bar represents 1 hour and the second bar represents 4.6 hours.
Okay, we're doing both time again. So that's kind of what he did. You did both time. Yeah.
The top bar was just the distance traveled, and the bottom bar was the time.
Okay, so I'm not putting this up because it's the right answer, because I kind of opened it up for you, last structure. But it was where I was intending on going, okay? So if you had something else, it's not necessarily wrong, but this is where I was going with this. So you said the distance traveled in,
And the time.
and this one down here is?
The time that the car traveled for.
Time travel, no? Time traveling, how about? Okay, and so then what, so tell me more. So
I split the bottom bar into the 4.6 hours, so I made 4 tick marks, and then left enough for 0.6, and then I split the top bar in a similar fashion.
So this is 1, 2, 3, 4, and then 0.6. Okay, and then what about the top bar?
The top bar I split in a similar fashion.
Okay.
I split it into 4 and left plus 0.6 at the end.
All right, so this is 0.6 of what? Point 0.6 of 72. Okay. So what does what is the whole length of the top bar? What does that mean to you?
72.
4.6 times 7.
That's right. All right, so we got 4.6 hours is going to be our time traveling, and then we get the distance traveled, which we can break up into the same four whole hours and 0.6 of an hour. And so therefore the distance traveled is 72 times 4.6. Okay, so what got scaled? What got scaled? The time gets scaled. From what to what? It did. This time itself got scaled. What was the scaling factor? Nope. 4.6. You took 1 hour, and we're scaling it up times 4.6 to get 4.6 hours. So time got scaled.
But in order to scale it from the bottom bar to the top bar, you are multiplying by 72.
Okay? So something else got scaled. What else got scaled?
You're scaling, you're not, I don't think you're scaling time there, because time, the amount of time you already have
Okay.
is 4.6 hours.
Okay.
You're scaling that 4.6 times 72 to get the top bar.
Okay. All right. That's fair. That's fair. So if we think of 4.6 as the scaling factor, this number that we're multiplying by, she's saying that scales on 72 to get the distance traveled in 4.6 hours. Is that what you're saying? You're scaling up, this is 72, right? And you're scaling that by 4.6 to get the distance traveled in 4.6 hours. Am I saying what?
Well, I think I'm not sure what you mean by scaling factor, because if it's the number that you're multiplying by,
Right.
it would be 72. Because even if you're only taking 1 hour, you're multiplying it by 72 to get one increment of the top bar.
So so you're seeing 72 as the scaling factor. Okay, that's fair. That's fair. What I wanted to show you was that if we think of 4.6 as the scaling factor, then which quantity is getting scaled by 4.6?
This is the reason everybody put distance as the bottom bar instead of time, because it would have made more sense.
Oh.
Because you, in your notes, you have 4.6 as the scaling factor, right? That's because the bottom bar was supposed to be distance, and 4.6 was supposed to be the scaling factor. But look at it. Bottom bar is 4.6, and the top bar is 4.6 times 72. By all the slides you've done, 72 would be the scaling factor here because you did time instead of distance for the bottom bar.
Yeah, so when I brought this example, so my intent was that this is kind of different. We're not, so before you saw that the longer bar was the scaled version of the shorter bar, right? So this is a different view on it. In this case, each of time and that's not incorrect, right? So that you're saying the top bar is 72 times longer than the bottom bar, right? True, absolutely true. And let's approach it a different way. Each of these 1 hour and 72 miles, aren't they both scaled by 4.6 to get the length of each bar? That's another way to look at it. So yes, to say that the bottom bar, you scale it by 72 to get the length of the top bar, totally right. Okay, but we can also think of 4.6 as a scaling factor where we're scaling up both time and distance. Both are getting scaled together. So if you multiply the number of hours by 4.6, the distance gets multiplied by 4.6. So I'm making a new point. We've got two quantities. If you scale one, then the other gets scaled likewise. Yeah?
Where did you get the 1 hour from?
The miles per hour.
Yeah, so miles per hour. So we're talking about distance in 1 hour. Okay, I want to go a little bit further. Any more questions about this one? So this brings up the idea of when two quantities changing together. If you scale one by a certain amount, the other gets scaled likewise. In this case, both the time of 1 hour and the distance of 72, we scale by 4.6 to get the new length of time and the new distance. Okay, we don't have time for that, but I do want to that one. All right, how about this now? So something new. The relative size of one quantity in relation to another. So how big one quantity is relative to another? Does anyone know what operation gives us that? What's that? Division. Good. So this may be totally new to some of you. When you do a division, you calculate a fraction, you get a number. And that number is the relative size of one quantity relative to the other. Okay, so building A is 17 meters tall. Building B is 5 meters tall. And therefore, building A is 3.4 times as tall as building B. And where did the 3.4 come from? It comes from division, 17 over 5. So we can do a bar diagram, but let's do it because it's buildings. We'll do it vertically this time. So let's look at building B. What am I showing in building B there? 5 meters. So each one of those blocks is 1 meter. And 1 meter is how much of building B's height? 1/5 of the height, so let's say the height of B. How many of those makes up the height of A? So 17 1/5 of B is the height of A. So the height of A is 17. So we're going to focus on division now. 17/5, which is this number, 3.4. So the meaning of that number as a quotient is what? What is the meaning of that number as a quotient of 17/5? Yeah, so isn't it, it's the size of A relative to B. So 3.4 is how tall building A is relative to how tall B is. So it's like you're using B as a unit of measure. If this is 1 unit of measure, then how tall is A? 3.4 of those. So that's the meaning for the quotient. That it's the size of A, but not in meters, in heights of B, heights of building B, 3.4 of those. So this is a huge idea for us all semester. Division gives us what we call relative size. Relative size. Okay, so let me put the checklist back up. Blackboard announcements. Don't do everything you need to do for Monday. 5 things. 5 things. Have a good weekend.